Good evening, everyone. My name is Nicole Cantatori, and I am the Director of Training for Worth Ross Management Company. And I would like to welcome you all to our June Speaker Series. For those of you that are joining us for the first time, welcome. We are so glad to have you. We design these exclusive events to bring industry-leading experts to center stage for a unique and uninterrupted experience like no other. You'll gain valuable insight, learn about best practices, and have the opportunity to ask questions. Our master speakers carefully are selected and familiar with the specific needs, challenges, and opportunities that association boards and managers are faced with. So before we get too far into the discussion, I do want to let you know that we are recording this session and we will make it available to our board members, along with other webinars in this series. So we want to make sure that all of our board members have the resources they need in order to best lead their communities. And that is what leads us to today's Speaker Series event. With me tonight is Brad Buckland, who is the Territory Manager for all North Texas and the Power Generation Plan Maintenance Services for Cummins. Welcome, Brad.
Thank you, Nicole. Thank you for having me here today, guys. I'm pleased to speak to you today kind of about plant maintenance itself, and as well as just kind of some generator basics. So let's get into it.
Actually, Brad, let me, I want to kind of just go over through the title real quick. So just to those of you that are joining us that don't know much about generators, basically it's going to be the ins and outs of emergency generations in condominium associations. So real quick to some housekeeping items. So the format for this evening will be similar to previous events, with our panelists presenting the information with approximately 20 minutes left at the end for Q&A. So if you have any questions that you'd like our speaker to address, please send them to me via the chat box, and I will present them to the panelists after he is done presenting and we move into Q&A. Now, Brad, I will turn it over to you.
Thank you, Nicole. Sorry, I jumped the gun there.
Quite all right. I know you're excited.
I'm always excited about plant maintenance. So I know me and Nicole were talking about how the storm probably brought on a lot of this conversation for those of us down here in Texas, and why it's important to keep up with generator maintenance and kind of what a generator and how backup power kind of flows together. So I'm happy to talk to you here about this today. Just want a quick little overview. I'm just going to talk about who we are as a company in Cummins, some generator basics, get into the plant maintenance side of things, and then we'll roll into questions eventually. So let's get this going here. So I'm not going to go through all of this here, but just wanted to kind of give you kind of a feel for what our company is as a whole. We started back in 1919 with Classy Cummins, a small town Indiana guy, which is where I'm from originally. So I grew up with just Cummins is all in Indiana. So Columbus, Indiana, small town. He started his own engine company and found an early adopter as he was side businessing as a limousine driver, and he put a diesel engine that he made in the limousine, and with its effectiveness and performance, the man he was driving ended up becoming his lifelong business partner because of how good it performed. So it kind of had some small, humble beginnings and kind of grew from there. And over the next 100 years, kind of fuel economy and performance is what we based our whole company around. And from taking a first diesel engine car into the Indy 500 to expanding into some global markets in the early 80s and 90s. Just kind of wanted to put all this together. You can read through this on your own time if you'd like, but just wanted to kind of put into perspective that we kind of come together as a company over the past 100 years, incorporating anything that has a diesel engine in it and really bringing it into our portfolio, into power generation specifically as well. And it just allows us to have a little bit of depth and knowledge, being the OEM who creates these products and then puts them in the field and kind of sees them through. So there's a little bit about us in terms of history and then kind of how we are now. We're kind of divided up into 4 business segments. The engine business, which has anything from small little 3-liter engines to 95-liter engines, which is about 8 by 14 feet. So it's a pretty big engine, and you can fit like 6 human beings inside of it if you wanted to. So we make some big stuff that's more specific to certain applications, but our engine, or for the power generation and for the plane maintenance side, we operate in this distribution business. And we kind of, as you can see, kind of evenly spread out pretty good across the company as a whole here. And as I said, we are a global company, so we're in just about every country you can think of. We have about 50,000 plus employees. That varies from day to day, that many employees, but I just wanted to also just know we are like a $19 billion a year revenue company. So we have a lot of just experience in a large customer base. So we get a lot of input. So we have a little bit more to go off of. And kind of bringing this down into where this is going to kind of play into effect with how I operate and how you guys are. You guys kind of operate, from what I know, from just more in the Texas area. I think you have some Rocky Mountain stuff as well. And I kind of primarily focus here in the North Texas area. But these are all of our service locations just for our distribution side of the business. So I'm based out of the Dallas branch that you see right there in the little red circle. And then if you can see up in Indiana, that's where Columbus is. That's where we started. That's where our headquarters is at. It's in the middle of nowhere, but it's up there. So with all these service locations and kind of how we start getting into where products and power gen kind of merge into one here, there's some energy solutions, which is those big giant engines that I told you about that are 8 by 14 feet right there. They're large natural gas engines, a little more customizable to large hauling tankers, to the electronic side of things with transfer switches and switch gears and a little bit of monitoring systems, all the way down to RV and smaller marine applications. But where this fits into the Worth Ross and condominiums is this commercial genset space. This is where 90% of our business is. This is where 90% of Cummins thrives in this market. So this would be more where we're going here today. This commercial kind of encompasses hospitals, high rises, apartment complexes. It does vary, but you're getting a piece of equipment that's good for a hospital or good for a high rise, because it can vary and it's kind of customizable. So kind of a little bit about just get into a little bit of the basics and products and a little bit of the knowledge. So KW is kilowatts, if for those who aren't aware, but the diesel side ranges all the way up to 3750, and then natural gas goes about to 200 or 2000 kW, excuse me. This is kind of because the natural gas side takes a larger engine to produce a similar output to what a diesel engine does. We do both because it has some benefits along the line, but they're kind of comes into play into what type of generator you want. Standby is kind of what we do majority of our stuff in, and that's what backup power typically refers to. That's your generator you have in your house. That's the generator that kicks on when something bad happens, power goes out. That's standby. Prime power, it's kind of as it sounds, it's the primary source of power for your generator, and it'll power your building. And when you come in the building, you turn on the generator, that's your power. And then the only difference between prime and continuous is, as it's simply said, it's continuous. So you're running that generator all the time, and they're built a little different just for continuous motion within the engine. You want to have a little bit more durable product inside those pistons. So kind of moving away from the generators a little bit is transfer switches, which I'll be talking a lot about today. You're probably very familiar with generators, or at least the idea of them. But transfer switches also play a really key factor in planned maintenance and just keeping your building operational in times of need for backup power. We also do digital paralleling switchgear, which is a little more industrial space applications. And we do a lot of remote monitoring control upgrades within the generator space. So we'll get into the controls and remote monitoring a little bit later as well. But looking at the generator here, this is a smaller generator. It's about 500 to 750 kW. And the engine of it is right here. So in this red circle, you just have your engine in here. and this is, I believe, a 15-liter engine. And then you have your consumables, which is your filters, some of your belts and hoses, things that are going to wear over the course of time and need to be replaced routinely. And this will get into the planned maintenance eventually, but those parts don't always come properly installed on some generators. Not all products are created equal. So that's why we routinely check them, monitor them, and change them out, really. Right here, you have your alternator and your breaker switch. So the alternator is this big cylindrical tube coming off the engine, and the engines, that's where it's actually powering the alternator to create the kW outage and rating that 500 and 750 I was talking about. You have your breaker switch on there as well, which is going to block out, or it's your breaker like you would have in your home, flipping the breaker on and off. And then up here on the top, this is actually one of our older control panels. Right up here is going to tell you basic things about your generator, how fast the engine's going, is there any errors, is there any system problems. You can start and stop your generator from here. You can kind of see it on here, the little red button that looks like do not push. It's the do not push button. It's the emergency stop button, which will come into play later here today. But the other kind of things, you can kind of operate the gen and turn it on and things like that from that panel. And then over here on the right is our automatic transfer switch or transfer switch. Most of them, in our case, we're going to talk about today, are going to be automatic transfer switches, which means it's automatically sensing power from the utility source and your generator, and it'll switch that automatically. Here, the important thing to note, there's a bunch of the things inside this thing, but it just looks like a bunch of crazy little wires. But out here on the outside, you'll be able to tell what is powering your generator, or excuse me, what is powering your building, the generator or the utility power. And you'll be able to switch it manually from your ATS unit. You don't even have to go to your generator. So that's kind of how they work together. One controls the other. And I like to think of this kind of in terms of, excuse the crude graphic here. I just made this last couple of weeks, but this is kind of how I think of it. It's how I was taught, and I feel like it works. So ATS is sort of your brain of the operation, and the generator is sort of your heart. So you have utility power coming in all the time, unless it's middle of February in Dallas, and everything's gonna shut down. But once you get into the utility power and the generator are all running into this ATS. So it's sensing it all at once. It's sensing if any loss, the ATS is sensing any loss of utility power, it's going to tell the generator to turn on at least. And if it's going to tell it to turn on, and as a safety precaution, if that utility power is lost. And this is all happening within seconds. And if the utility power ends up being lost, it kicks on the generator and flips that over into your main power for your building. So that's how they kind of work together. So that ATS is not always as, it's not your big ticket item, if you want to say that. It's not as flashy as the generator might be. And in my world, that's flashy, I guess. But it is important to note that it is the big primary source of some issues that might occur in terms of not having planned maintenance and things like that. And just kind of note here too, I wanted to mention the ATS is going to power whatever is set up on your emergency power system. So typically that's your lighting, elevators, in this case for this building here. Some security systems are often set up, but it does vary. And it can be adjusted as needed, but it really is only powering those emergency systems that are set up at the beginning of the building. Here. So how does this kind of all play into planned maintenance? So we kind of know how the generator's been functioning, the basics of it, and why things kind of go wrong or how they can go wrong. That's kind of the point of planned maintenance. Just like when you take care of your car, you're going to want to take it in to get its oil changed, hopefully every year, or whatever the mileage, you get a little sticker. Same thing with kind of planned maintenance, same idea. It's also referred to PM, or planned maintenance. It's all kind of same vernacular, all meaning the same thing. Just checking in on your generator is the most basic way to say this. And the things it could kind of do, it can decrease the likelihood of any problems or any major problems coming up down the road. You'll be able to detect any small problems in any of the fluids, any of the visual checks as this tech here is doing. He's checking the spark plugs to make sure there's no damage done to them. And you're also able to just eliminate surprise large amounts of money that could be costing you if you're not checking it routinely or having any cascading damages because of some one part goes wrong that you hadn't been checking. Also just kind of keeps your budget and your costing routine and the same, and you can put it into your budget. I know how important that is to everybody. Budget is always a concern of everybody's. If it's not, I'd love to talk to you. But if you keep it all routine, and you're really limiting any downtime and risk of having to have a repair tech come out. Because as an industry standard, repair techs are typically higher level technicians who come out, and it could be after hours, it could be in the middle of snowpocalypse, which just incurs a higher rate just across the board, and might not have parts available and planned ahead of time like we would, because each engine's really specific and kind of niche to what it has. So it's hard to have every single part available on an emergency call if there was something going on. So you might have to come out again, and that's just sort of just the way of the nature of the beast, I should say, as far as repair goes. So that's another kind of little caveat as to why you should think about adding planned maintenance or just keeping a routine maintenance plan in your portfolio of things to maintain that generator. So that's kind of the overall stuff, but the actual services that kind of go along with it and some of the vernacular here. So a PM1, an inspection, sometimes referred to just your quarterly or your semi-annual maintenance, all the same words, but this is your visual check that you just check in, your general health checkup that you'll get every year at your local doctor kind of thing. You're just checking in, you're making sure that everything's all right. You're not actually changing any of the filters. You're not changing any of the oil. You're just looking at it, making sure there's no weird issues. Surprisingly enough, the biggest issue when you're doing these multi-point inspections often comes down to the batteries and the battery charging systems, because the batteries need to be changed out every 2 to 3 years. And they're just kind of sitting there underneath the gen. They're big suitcase sized batteries, but not having those replaced every 3 years. Every OEM I've ever heard of is always recommending you change them every 3 years, because everything could be fine. Your ATS could be working fine. Your generator could be tip-top shape, but if you don't have the battery, you can't turn on your car, you can't turn on your engine here. So similar scenario, but that's the single most point of failure in any repair or any downtime of a generator is the battery, just not having it charged and ready to go. So that's kind of the visual checks. And when we're doing these visual checks, the reason it's nice to have these throughout the year is because if you're not out on site or you manage multiple sites, there's some surprising damage. And because a lot of generators are outside and they're in a warmer enclosed environment with, typically they have block heaters inside them, it creates a warm environment for some friendly critters. And oftentimes you'll have squirrels, rodents, cats, bees, you name it, hiding inside of these generators. So what rodents love to do is chew on some of the cabling, which damages your gen. You might not know your gen's offline. And that's why coming in quite often, it's good to just check and visually see if everything's okay in your gen. Even if you don't have planned maintenance, it's good to go out there and at least check and make sure you don't have any critters roaming around there. I've opened up plenty that have bees nests in them. Those are fun times, but just checking in on them regularly is always important for us. And with that, we have an annual service, full service, PM2, kind of the nomenclature there, for the actual change out of filters and oil, little bit more of an intensive visual inspection. We kind of get into a little bit more into the control system. And as well, we do a lot of, they're additional services, but they're really more so required and recommended by us in terms of what you need to fully take care of this generator and make sure everything's in tip-top shape. So those additional services, there's a bunch here, and we'll read through some of them here, but kind of the bigger ones are with the air filter belts and hose replacements. That's sort of an every 3 to 5 year kind of standard we have within the industry, because those kind of wear out over time. However, if you are checking in your generator and there's a hose leak or a little tiny crack, that would be something we would note and make sure when we come out next time we have that part available and ready to change out. That way you're not paying someone else to come out when it springs a leak, you lose a lot of fluid, and you're down, and you have no reliance on that generator. Because everything about plant maintenance is just to make sure that when your generator isn't, it's out of sight, out of mind, you're thinking not about it, but when it does snowpocalypse happen, you can trust it and have it ready to go. So that's where a lot of these additional services kind of come in with the fluid sampling, the building load test, which a building load test is it's a common industry term, meaning we're just putting the generator on to the building power. So we basically turn on the generator as if the power is lost, and you manually switch it over to your building's power or load. So it's just the requirement of your building at that time. So a lot of times this does get inconvenient though, because you are putting everything onto emergency power. If you have tenants, it's not a fun thing to tell them that you're shutting down your building for a moment to change some filters and things like that. So what we kind of offer as a whole to kind of alleviate the most inconvenient things is this sort of package. And this is the standard one that we recommend as an organization, as a manufacturer, is that annual full service we talked about, that ATS that we kind of went through earlier, an ATS inspection, so like a visual inspection, quarterly maintenance, just checking on it visually, a 2-hour load bank, oil, fuel, and coolant analysis, and then a battery change out kind of every 2 or 3 years. Sort of depends. Usually we like to get it within that 2 years, but obviously people stretch that out because their batteries, and then that's not to say that it's impossible that your batteries aren't going to live for 5 years, but a lot of times they shut down at 3. So that's why we recommend between 2 and 3. So kind of like a schedule would break out. Just a basic one would be kind of the whole kit and caboodle here in the January service of this would be your annual, your PM2 with these services. So you'd have the 2-hour load bank, you would have the oil, fuel, and coolant analysis that detect if there's anything wrong, and ATS inspection. And then these April, July, and Octobers are the actual generator inspections. So you're really looking at 4 times a year, someone coming out there, a little bit more of an intrusive thing on January, but with this load bank performance testing that we do, the 2-hour load bank, this is really kind of how we get around using the building load test and taking your time away from your tenants or whoever's in that building and not inconveniencing anyone at all. So how this works is this load bank here on the right, it's just a resistive load bank. So they're designed to just test the generator and simulate a generator taking on a building's load. So that load bank will be rated the same rating, so the same output as your generator is. And we test it at certain intervals, disconnecting it from your main building, so you still have utility power, it won't inconvenience any customer you have. And we test it as if there was a failure in the building. So the generator is running at full for 2 hours. We kind of vary that based on the recommendations by OSHA and the National Fire and Safety Protection Agency. They kind of guide our standards. It's a nice 300-page document. If you want to read through it, I can provide it. But that's how we base our standards. And this right here, you basically just hook it up to the load bank. It helps prevent some wet stacking, which is when your generator doesn't operate at full capacity all the time. Some models of generator, it's just kind of a residue that kind of starts coming out of the tops of the pistons of the generator or on the engine, and it can cause some damage. So it helps put your generator to the test and simulate it like power's been out once a year. That's always good to have to make sure there's no issues. You can detect a lot of things within this test that might not commonly be seen just by looking at it visually or changing things out. It's really just putting it through the paces. And this is kind of what a report vaguely looks like. So this is actually a real report we took this is from a hospital. We as a company, we operate and do plane maintenance on all different types of equipment. So this is actually a Caterpillar engine that we're working on here, and we're doing the load bank for this hospital. So they have a 4-hour requirement based on their Joint Commission standards, which is right here at the top. It says standard NFPA 110, which is the one we always operate off of, and then any additional ones. So hospitals every 3 years have to have this 4-hour load bank instead of a 2. So just to kind of quickly go through this and just show you how this report looks for you. So when you get one, or if you have one, you're kind of familiar with it, and it doesn't just look like a bunch of numbers on a spreadsheet. So right here on the left, this is how the Joint Commission and NFPA recommend you test your generator. So it's 30% of the load for the first hour and a half or so, or excuse me, this is 4 hours, so about 3 hours. And then the last one, you're at 75. We can test it at anything. We do a lot of 100% all the time during the load step. It really is a customer preference, but the standard that we typically operate off is that NFPA 110. And what we're checking here and how this leads to not seeing things you wouldn't see in a visual check, or changing filters or looking at your control panel, is these phases right here. And then it says load percentage. You'll be able to see if there's any variance in the change, or if there's any problems that might be in the alternator, which is the spinning that's actually creating the power. And you'd be able to detect kind of high pressures, low pressures, temperature changes within the unit while it's testing on a cycled load. So you'd be able to detect a lot of things that you wouldn't necessarily be able to see before. So when you would get these, a lot of companies, have their own kind of version of formatting all this, but everyone should have this across the industry as far as a form to hand you, so you can see it as well. A lot of people keep records of them, just that way in case someone asks you about it, you have, hey, we've tested this for 3 years with no problems. And it just creates a history for the gen. So you're not working off of no information, and you're eliminating guesswork, which is kind of a little bit of that planned maintenance, big advantage is eliminating the guesswork, eliminating repair times, if any, and moving forward with a good as new gen. So as I mentioned in the OEM recommendations, a transfer switch inspection is pretty key to just making sure the brain of your system is actually working. It's going to flip it on and turn it on and off when you want it to. So for our instance, minor services is the recommendation that we make. And it's really just because it's a visual inspection. You're making sure there's no rodent damage. Chewing the wires, once again, a warm environment attracts just the friendliest of wildlife, and they'll nibble at that stuff. So you're just really checking to make sure it's going to flip and make sure you're good, and it's actually going to be good to go when you need it. And I like pointing this out because there is a bigger issue in terms of the industry switching towards a safety protocol that was just put into place a couple of years ago, and it's kind of been transitioning into planned maintenance work. But these ATS units have constant utility feed from power coming in. And it's kind of semi-exposed. So if any dust or debris or it sparks or something, there's something called an arc flash that comes off, and it's an explosion and it can kill people, and it's very hazardous. There is the standard we have to operate off of for these is it's called an arc flash assessment. If you have a newer ATS unit, it should have had it done by the electrical contractor when they came out and did the original assessment. But really, it's a sticker telling you how dangerous and how much instant energy is behind that ATS. So even if you're not servicing these, I mean, for 30 years, there was technicians in the field opening and closing these things, no problem. And then one or two, issues occurred, and it kind of sparked a lot of change within the industry. So even if you aren't servicing these, just as a call out, make sure there's an arc flash sticker on there that tells you how much energy is behind it, and it'll have like a little rating in calories. And anything over 40 calories we can't operate on because we don't have enough safety equipment to handle the arc flash. Some of it up to 40 we're good, and we can work around in it. Everything else we have to take the building off of power in order to work on that ATS. So it gets kind of inconvenient if that arc flash assessment isn't done for us and for the customer, or for you guys. So you know, there's no downtime. You're not really waiting on something to pass your clearance, and you're not finding another you know, liability thing, you know, in your building. And the major service is when we have to de-energize the building. We're actually getting into the nuts and bolts and tightening things, and it's a little more extensive. And it's not required, and it's not really even recommended for this small of an application or condominiums. Once you get to the larger things, you want to get those checked out, just because there is more instant energy behind there, so there's more likely a problem. Moving along here. So I did mention that there's an oil, fuel, and coolant analysis also in that OEM recommendation. I'm not going to go into all these. It's a little dry. These analyses are done while we're doing the full service. It's one of those things, like getting your blood taken from the doc. You actually get to see why your cholesterol is high. You know, you're looking for debris in this case, or corrosion, or, you know, just water in your fuel, which is bad. And getting all those things checked out it's not a very costly analysis to have run, and it really can save some long-term damage to your generator and keep that health of it alive. And sort of these will give you a little bit of a health checkpoint as well, because if you keep your generator healthy, clean, and you're testing it in planned maintenance, your generator, I've seen generators in the field from the 80s still. It's really you keep it as good as you can, and what happens is the technology eventually catches up to where there's more efficient controllers. There's a lot of upgrading. So your generator most likely won't be the one failing on you. The technology is just going to catch way too far up on it. But it won't break down. It's your iPhone 12 and 15 we have now versus, you know, your iPhone 4. So that's why we test some of those things, to make sure we can keep that generator, you're not having another costly expense of buying a brand new gen. So when a fuel polishing is required is when those fuel analysis come back with water, debris, sediment, corrosion. We run it through, basically it's a tanker truck, if you want to think about it like that, with a giant filter in it. There's a couple filter layers that kind of take it out. And it's a lot more cost effective than having to remove all of the fuel in your tank. So it really cleans your fuel, and you don't have to worry about any of that water that might be in there, and not touching it for 6 to 12 months is kind of when we start to see, if you're running a fuel analysis routinely every year, you really don't need to worry about your fuel being dirty, or you're getting that checkpoint every year. But if you're not looking at it every 6 to 12 months, and it's not above 75% full, which is kind of our recommendation, it kind of varies. It's 75% at the minimum, just because one, you want to have enough power, enough fuel to keep going throughout any emergency, but you also want to just make sure that, you know, if these are outside tanks, you're not dealing with as much moisture. If there's 75% or plus full, there's just a little bit less room for air there. Kind of moving through the industry here. This is what our extended warranty coverages kind of go into. This is pretty standard though. Breaking it down between, right here, we're going to focus on the commercial here and the ATS here, but breaking it down by parts and labor, parts and travel is very common. But just a call out I wanted to make here is when you do look at extending your warranty on your gen for anything that may be going wrong in a factory setting, if you bought your generator in 2018, you would have to, and it came with a 2-year warranty, you would have to extend that warranty within the original period. Otherwise, it won't be effective, and you won't be able to do it. That's an industry thing, just because we don't want to cover it in that little gap, I guess. But just wanted to call that out, because that is a little caveat that sometimes gets a little confusing as things kind of go through on the planned maintenance side. Kind of lastly, and I know this is probably going to be a big topic of questions, and I'm more than happy to field anything afterwards as well. But remote monitoring is, especially since the storm and not being able to get to your site potentially, and having a sense of, hey, what's going on there? You might have a maintenance guy or someone on staff who's there trying to describe it to you, but you could. There's a lot of systems out there, not just ours. I just know our product here, but we have fuel sensors that you can put in, so you know how much fuel you have, which will help tell you how much you're going to be able to last on that generator. It'll tell you some basic output readings that you're getting, any error messages you're receiving. So if for some reason you have a high voltage alarm that you don't know what it is, you can easily tell what it is via an app remotely. Don't have to be on site for anything. You can remotely start your generator to test it if you'd like. It hooks up to your ATS and your generator, and you can get some more basic information on that. And they kind of all work together to just provide a package that allows you to not worry about things. One little more thing you don't have to worry about with fuel, and is my generator good to go? I know, hey, it's going to be cold this, it's be 32 coming up. How prepared are we? You can check and test the gen on its own without putting it on to building load, just testing it, make sure it's going to turn on. So outside of that, I got a little quicker than I wanted to get through that, but we're running up on the questions here, Nicole. So if you wanted to hop in here.
Yes, we do have some questions that's come in. Thank you so much for that information. And you've probably covered some of it, but these questions that have come in, you'll get to delve in a little bit deeper. So the first question is, how often should the transfer switch be tested?
Yeah, so I touched on this one a little bit, but the primary vision, if you're going to inspect it at least once a year at the minimum, it should be, that's our recommendation. But once again, it kind of gets into the arc flash assessment. And it kind of gets a little bit, if you don't have that done, it can take a little bit of time. And getting into the ATS, I would consider almost a bonus of checking that, should make sure that system's good. We can kind of work around it, like I said, with that building load test, but it kind of gets a little inconvenient at points if you get to having to put it on emergency power. So once a year is probably good enough for just a minor visual inspection with this application.
Okay. Thank you for that. Next question is, how many gallons per hour does a diesel generator burn?
Right. So this question does vary, and I'd be more than happy to help anyone who has the specifics on this, but everyone should have gotten at least an owner's manual in their preparation of getting the gen, and it does vary. So if you are on like 25% load versus 75% load, it's a huge factor in terms of, it's like running your car at 80 miles an hour versus in neutral. So it's same kind of fuel economy. If you're running with your building's only requiring 25% load, it's going to take a lot longer for that fuel tank to be used. But I have the ability to find all that information for specific engines and generators. So if there is that specific question for yours, I'd be more than happy to just send you, what it looks like and how it's going to play out in the fuel economy kind of thing.
Excellent. Thank you. Okay, the next question, pros and cons. Can you kind of review the pros and cons of diesel versus natural gas generator?
Absolutely, yeah. So diesel and natural gas, it's especially since the cold snap, I will say this has been the most frequent question I get asked, along with fuel tank stuff. But with natural gas and diesel, so the pros and cons. So diesel, you have a much, I will say, robust and output product. So for natural gas, the burn rate required for natural gas combustion requires a larger engine for a similar output in a diesel comparison. So, for example, there's a 15-liter engine on a natural gas generator. It would require, a 15-liter diesel engine is required for a certain output. It would be a 30-liter engine, which is double the size, and it increases your footprint a little bit, increases the cost because it is a larger engine. So you are going to be increasing your costs that way. And the big takeaway here was with natural gas being, okay, I don't have to worry about filling that up. I don't have to worry about, because especially with the cold snap, we had 4 days of not being able to go anywhere. So fuel providers are having a tough time, getting to places. And people are running out of fuel because they're running their generators for 3 or 4 days straight. The problem with natural gas supply sometimes becomes the issue. With diesel, you can have a little bit more control, with adding a fuel tank or doing something along those lines of just having extra fuel storage, around, or having an agreement with your supplier to constantly have that generator good for a catastrophic event. Whereas with natural gas, you're kind of at the whim of your supplier. So in most of North Dallas and even some of South Dallas, the supply was increased by the natural gas companies as a precaution, because they're like, hey, everyone's going to use natural gas here. However, there's a certain PSI. There's a lot of little things that kind of go into the natural gas, being able to function properly and being able to start that generator, that if there's not a proper amount of supply constantly coming out of that generator, or excuse me, out of your natural gas supply, your generator might still not start. So there is still a little bit of concern, because a lot of people in Texas have exposed natural gas lines. Now, if you have an indoor generator and no exposed natural gas lines coming in your building, it's less likely that there could be an issue with not having a supply. But once again, you're still at the whim of whoever, is your supplier, like Atmos or someone like that. You're at the whim of what they have. So there's kind of give and take with it, a little bit more expensive in summary, and maybe a little less control over your fuel supply with natural gas. But if you have a reliable natural gas provider, it's a good way to go. So there's a lot going on. If there's specific questions, because it kind of gets into specifics with a lot of these sites. So if there is any more, once again, just I'll have my contact information here, but feel free to reach out to me on these, and I field these questions a lot, so all for it.
Excellent. Okay, next question. What are some things that need to be handled by an electrical contractor versus the generator provider?
Right, so there is a lot that how the business model of just power generation works as an industry is that an electrical contractor or electrical consulting engineer has a project in which they're building, let's just say, a high-rise downtown. They reach out and they bid out to all the providers about having a generator with X kW rating, and that's about it, and where they want to put it and kind of some specs around it. There is no control on our end or any provider of a generator themselves or plan maintenance to change anything that goes into that gen. So I know this is a common question about what systems are kind of getting powered by the generator. That has to be handled by having an electrician coming back out, determining how much more you can put into that generator, because a lot of times there's only lighting, elevators, and some security set up on it. So not always are you using the full capacity of your generator. So there might be some room to add some systems into that to put into place. But that the arc flash assessment has to be done by an electrician. There's a couple other smaller things if you want to add another, if you want to add another ATS, you want to add another generator, we can provide the generator, but we can't provide the specs that kind of go with it. Like, hey, I want to add this much to this gen. How much would that be in terms of adding kW? That would still be an electrician. So there's a couple there that kind of get caught up with the generator and what's coming into it, but that really has to be an electrical engineer, electrical contractor, or electrical consultant.
Excellent. Okay, thank you. Another question came in. Does natural gas operate better at lower temperatures than diesel?
So it depends how low. I know these are a lot of depends questions, but it really does. So if you're operating at really, really cold temperatures, and a lot of people, I'm sure this year will start to winterize their diesel fuel for the upcoming year. In northern states, it's very common. That's practice for us back home. I mean, we get ice and snow all the time where I'm from. So, no one winterized their fuel when they came down here. So there isn't as big of a issue down here, obviously, but coming up on the winterizing your fuel will obviously lower the freezing point of that diesel fuel. So as long as if that generator is running and your fuel is not frozen or sludged or or, when I say frozen, it has a little bit of water in it, and if the water froze itself, as long as that's not an issue, your diesel engine is going to be warm and running as long as you have diesel fuel. The natural gas kind of aspect of it, like I said, it can affect the pressure as far as if it's an exposed natural gas line to the generator, it's going to have the PSI coming in might be great, but if that's exposed, it's going to slow down some of those gas molecules, and it might not be enough when it gets to the generator. But if it's an enclosed natural gas system underground or in your building, there shouldn't be an issue with temperature regarding fuel for natural gas.
Okay, wonderful. Okay, the next question is, what should be considered as far as maximizing the current capabilities of the generator?
So if you want to maximize your current capabilities, let's just say you're at 100% of usage on your generator, and you want to just get more out of it without adding, getting a new generator up, increasing the size of your generator. Adding a fuel tank, I know that there's some customers in my area that have added a fuel tank or looked at adding a fuel tank, and just it's called a day tank or a fuel tank, and that'll help just create another supply of gas, or for diesel, to your generator, and you'll have a little bit more runtime per se. And having remote monitoring also might help in maximizing like the full potential of your gen, because you'll be able to read into things and see how much power you're using at certain times a little bit easier. You might be a little bit more aware of kind of how your generator is testing and functioning. But outside of that, and not adding anything else, that's kind of how you maximize it. And just making sure that you're at least looking at it routinely with a technician from anyone's staff, or just getting out there and looking at it. Just familiarizing yourself kind of helps take away a lot of the guesswork in terms of what, the unknowns. And that helps a lot in terms of conveying your questions, having, planned maintenance properly set up in your stuff.
Great. Thank you so much. Next question. I think we just have a couple of more. So I remind everyone, if you do have questions, feel free to submit those because we do have time for more questions. The next question is, are you seeing interest in larger capacity generators to be installed in high-rise buildings to power more systems? I know you touched on that a little bit.
Yeah, so I am seeing there is a larger, generators are getting bigger and bigger in terms of hotels, condominiums, apartment complexes. They're getting bigger and bigger because I assume people are putting more on them. Once again, we kind of have that little gap in knowledge between the electrical provider, the customer, and then the generator provider. So they're putting more things on there, or at least giving the capability of putting more things on there. So the larger your generator is, and if you know what is backing it up, there is a potential that there's room to grow within your own generator. But in terms of the entire industry is moving to bigger and bigger generators because they're getting a little bit more efficient, and pricing is getting a little bit better as a market. So they are getting bigger, and buildings are getting taller down here too in Dallas. So
through all of Texas, actually.
Yeah, I'm sure Austin's pretty bad too. Yeah.
So are you seeing more, another question that popped up, are you seeing that it's more popular to have natural gas generator compared to a diesel generator?
No, so I want to say it's probably 80-20 diesel to natural gas. So a lot of that's probably got to do with pricing, and when it comes to the end user, I guess, because you're working with usually a project manager, someone who built the building, electrical contractor, a bunch of people are kind of involved in that, and they're not as always concerned with, hey, we want this to be natural gas. So that's something you can kind of pass upstream on your guys' end if you are involved in any newer projects. Hey, we want natural gas. Hey, we want diesel. Kind of making that known at the front end is kind of the only way to manage that situation. But it is still 80-20 roughly in the market. A little bit more of a spike probably since the storm, but not a whole lot, to be honest with you. So it's been pretty consistent.
Okay. And the last question that I show here is, in a scenario of adding an emergency generator to a high rise, what are the pros and cons of diesel versus natural gas generators? I know you've touched on a little bit, but it looks like they kind of want a little bit more clarity regarding what the pros and cons would be.
Yeah, so if you're putting it in a high rise, so a lot of what goes into high rise buildings, especially if you're adding it on to an existing building, you're gonna have to worry a lot about footprint in terms of where you can fit this. If it's going outside, it's a little bit easier, but a lot of times with high rises downtown, you're working off of very small square footage that you can kind of fit things into. So like I mentioned earlier, the natural gas, usually for the output that you're gonna want to add, it's the size footprint could be a couple more feet wider and just a little bit more intricate to work with. The diesel aspect of it, if you're working at a high-rise building going up downtown, you're not, to be fair, you're not going to be dealing with a storm like we had, every 30 years. So diesel is still my recommendation always, because you're usually not going to be working off of 4 days straight of no one being able to go anywhere. So I still push diesel as my, and as the industry, it's still pretty common to have diesel more than natural gas, even in high rises. I don't know of any high rise, especially in the Dallas market, that operates off of natural gas. And that's our engine. So that's kind of my little 2 cents on it. If you have a more specific question on that one sounds like they might have a little bit more meat on the bone there. So feel free to call me, whatever, email me. I'm more than happy to help.
Okay, great. Thank you. I know you touched on this a little bit, but I guess more clarity on what would be maybe the top 2 or 3 challenges of having your generator outside. You had mentioned like rodents and
Yeah,
different things, but is
yeah.
there any top challenges that you find in your industry?
Yeah, so with being outside and with being Texas and being hot all year round and being outside, you have to deal with a little bit more of a fuel. There's some more fuel issues that arise, and that's why that testing is kind of important, because if you're constantly heating and cooling any liquid, everyone's left a water bottle in their car that they shouldn't have, and it lasted there for 2 months. And things happen, water, just moisture, bacteria growth. There's a little bit more of an issue there. I'm a little, not like concerned, I'd be a little more aware of how my fuel is, how often it's being touched, how often it's being looked at, and just being a little bit more cognizant of it. And as far as like outdoor other things like rodents, like I said, there is measures you can add into your generator and stuff to keep. It's literally like rodent prevention, like equipment that we have to like kind of add in to make sure there isn't any issues there. But with the rodent kind of comes with, just check go look at your generator once in a while. It sounds kind of easy and simple, but like for the most part, if any layman can come out and say, hey, there's blue liquid laying on the floor of this generator, it's outside, there's a little bit more heat. Like I said, hoses, expand and collapse a little bit more. So there's just checking on it is really the only additional challenge that would be outside more so than inside. But there isn't a huge, like, if you can put it inside, that's great. And you want to put it inside, it's great. Most of the gens that I see are outside. So it's not like it's a burden to have it outside more so than inside. More convenience.
Okay, great. I'm checking to see if there's any other questions that have come up. I do not see that there's any additional questions. We have about 6 minutes remaining, but if there are no other questions, I'll give everybody just a few seconds just in case. But in the meantime, Brad, thank you so much. Really appreciate you taking the time to go through this information, especially since that storm. It's been a hot topic, definitely.
Yeah, no, I appreciate the opportunity to come on and just talk about planned maintenance and just generators in general, because I will say there's just a lack of hey, I've been in 3 or 4 different business segments here. And I know there's a lot of nuance to things that you just don't see a lot. And generators kind of comes up as one of them sometimes. So more than happy to answer any questions or follow up that might happen. I'm a person who I like to talk. So cell phone is perfectly fine if that works for you guys. If there's a bunch of requests, probably email because I'll have to get to them. But I'll call. But I do appreciate the opportunity, guys. And if you have any questions, let me know.
Excellent, everyone. You see Brad's information there. I just wanted to remind everyone that we are recording this, so it will be available and uploaded to our YouTube channel. So once that is available, I will send the link out to everyone. So I don't see that there's any more questions. So I just want to thank everyone for taking the time to join us. And again, we will see you next month. And I hope that you all have a wonderful evening. Thank you again, Brad.
Thank you, guys. Appreciate it.
Take care, everyone.